Hello, in this video I'm going to show how to use Proteus to debug assembly programs for STM32 microcontrollers. Let's get started. With each lab, we will release a Proteus project. For this demonstration, I'm going to use the project for lab 0. Once we open the project file, Proteus will show the schematic. The big box in the middle of the schematic is the STM32 microcontroller. There are other components such as the LED, push button, and some passive components. You do not need to change the schematic, and therefore we won't be covering much on how to use all Proteus features. Before we start our debugging session, we must load the program on the STM32 microcontroller. Loading a program is simple. Double-click on the STM32, then click on the Open File dialog. It is the button next to Program File. Select the .elf file from inside the Objects folder. Click OK to close the Edit Component window. We are ready to run the simulation. It is important that you do this or the path may be wrong and Proteus will not find the .elf file. If Proteus fails to find the .elf file, it will throw an error. To run the simulation, go to the bottom left toolbar and click on the Advanced Simulation button. If the Source Code tab is open, then the simulation will start on the Source Code tab. Otherwise, the debugging panels will appear floating on top of the schematic. Since we are already in the Source Code tab, let me present it first, and then move to floating panels. I must say that none of the debugging views is better than the other. As you can see, the Source tab view allows you to organize the different debugging panels in a way similar to most development environments. You can add or remove panels and arrange them depending on needs and like. To add debugging panels, go to Debug, CM4. CM4 is for Cortex M4, and add the panels you want. To arrange and remove panels, drag and drop or undock/redock them as you like. For example, to add the GPIO-A, go to Debug, CM4, click on GPIO-A, undock and reposition until you can see all registers individually. Notice that the source code view shows all the source code, including comments. The executable code is preceded by their address in program memory. Only executable code can be debugged. If you do not see the address, it cannot be run. But that does not mean your code is wrong. For example, most assembler directives do not yield executable code, but they are an essential part of your source code. The debugging session can begin after you set at least one breakpoint on the line you want to pause the simulation. Let's put the breakpoint on the first line of our code. To set up a breakpoint, you can double-click on the line or press F9. A full red dot indicates an enabled breakpoint. If you keep clicking, the breakpoint will change to an empty dot indicating a disabled breakpoint. Keep clicking to remove the breakpoint. Let's put the breakpoint back, and we will be ready to start the simulation. To run until the breakpoint, click on the running person or press F12. The simulation will pause at the breakpoint, and from there we can start inspecting the code using the various options from the debugging toolbar. Remember that you can always use hotkeys to go faster. The debugging buttons are quite intuitive, and you can always check hotkeys and names on the debug menu. Please notice that some debugging buttons may not work as intended. Why? Well, when we program in assembly, it's harder to tell where a function call begins or finishes. You will know in a future lab, but the .elf file will not contain that information. The debugging buttons will work well for languages such as C. During any debugging session, we will watch the CPU registers. Most registers are visible through the register panel. When we step through the program, we can see the registers changing value. That's it for the debugging introduction using the Source Code tab. If you close the Source Code tab during simulation, the simulation will stop. The next time you run the system, the simulation will start with floating panels. The floating panels view is useful when we need to debug while interacting with our system. For example, in Lab 2, you will use an LED and you would likely want to see the LED turning on and off while stepping through your program. You may have noticed that all debugging features are available in this view as well. The only difference is that it makes interactions with your system a bit easier. Let me show you an interesting feature of debugging with Proteus. In Lab 1, you will need to measure the time used up by a delay. You can measure time differences with Proteus. To measure time differences, we need 2 breakpoints. Let's make the first line of code the first breakpoint, and the line before the loop the second. Let's restart the simulation. Notice I am using the play button. Because I have breakpoints in place, the simulation will pause automatically at the first breakpoint. Now, let's run the system until the second breakpoint. Proteus will provide the time elapsed between the first and second breakpoint. In this case, 1.3745 microseconds. Be careful what you do with your mouse. If you move the mouse outside the panel, the message will change and your time measurement will be gone. I hope you enjoyed this video.